Good afternoon, everyone. Myself, Poorinima from 11th Integrated JW Girls Batch, Acharya Academy. Today, we'll be teaching the topic Early Attempts for Classification of Elements. So, let us begin. First of all, we'll start with a general topic, that is the periodic table. At present, 118 elements are known to us. Around the year 1800, only 30 elements were known. Initially, as the elements were very less in number, it was easy for the scientists to study them. But over the years, more and more elements were discovered or synthesized artificially. Due to this increase in numbers, the scientists felt a need to classify them according to the similarities and differences in their periodic properties. So currently, we use the periodic table to classify the elements. This periodic table is also known as the modern periodic table and is the most successful method which is currently in use. This is the periodic classification of elements on the basis of groups, that is vertical lines, and also in periods also known as the horizontal lines. There were many early attempts to classify the elements and it dates its way back to the 1800s. In this session, we shall be discussing about the main three ideas given by three scientists, that is Poorinima, Newlands, and Mandela. First of all, let's go to Poorinima. The ideology given by him is also known as Poorinima triads. The person we see over here in the photo is none other than Johann Wolfgang Poorinima. He was a German chemist and he was the one who gave the idea of Poorinima triads in the year 1870. He tried to arrange the elements, which was then known to him and were 30 in number, into triads, that is, groups of 3 elements each. So here we can understand, after he started calling them as triads, the name came to be known as Poorinima triads. Let's see. Initially, he found out 3 triads, which consisted of alkali metals, lithium, sodium, and potassium, alkaline earth metals, calcium, strontium, and barium, and then the halogens, which consisted of chlorine, bromine, and iodine. While studying this, he understood that when the elements were arranged in order of their increasing atomic masses, that is, when they were arranged in order of their increasing atomic masses, the average of the first and the second element was roughly equal to the atomic mass of the second element. Here, we need to focus on the point that it was roughly equal. So, from this, we can understand that it was mainly most of the times equal, but at some points it was unequal and it was approximately to the average of other 2 elements. So, let us see the case of halogens. When it is the arithmetic mean of the first and third element is done, it comes out to be 81.5. Here, we can consider this to be roughly equal to the mass of bromine, which is 80. But in case of alkali metals, when we do the average, it comes out to be exactly 23 and is exactly equal to the mass of sodium. So, the same way it goes on for alkaline earth metals too. As it is said that the coin always has 2 sides, there were some limitations of Poorinama's method of classification too. Poorinama could not incorporate all the then known elements, that is the 30 elements, into the triads formed by him. He could make only the 30 elements. What he understood was, even though the elements had similar chemical properties, they could not be incorporated or accommodated into triads. For example, nitrogen, phosphorus, and arsenic. The average mean of both of these was equal to 44.45 atomic mass unit. But this was way greater than the atomic mass of phosphorus, which was just equal to 31 atomic mass unit. So this was a great exception and proved that his theory was wrong. And another thing which was a drawback of Poorinama's triad was that There were many elements which had similar characteristics or properties of carbon, nitrogen, and oxygen, and they did not verify his theory. So these limitations altogether led to the failure of Doberan's theory of triads. Now let us move on to the next one, that is Newlands Law of Octaves. The person here is Newland, who was also known as John Newlands, and was an English scientist, and he was a great music enthusiast. Being a music enthusiast, he compared the notations for music used in the West that includes do, re, mi, fa, sol, la, ti, and the elements available to him, which was equal to 56. So when he compared them, he came up with a law which is now called as the Newlands Law of Octaves in the year 1866. He found various similarities between the notations and the theory he had come up with in the elements. Let us see what he had come up. So these are the notations used in the West, which is similar to the Indian notations. That is, do signifies sa, re, ga, ma, pa, the, ni. And as it is, sa repeats itself after ni, do too repeats itself after ti. Similarly, he understood that when elements were arranged in order of their increasing atomic masses, every eighth element was similar to the first element. So out of this, he clarified that fluorine had properties similar to hydrogen, sodium to lithium, beryllium to magnesium, and so on. In this point, we had seen the advantages. Now let us talk about the limitations or drawbacks of Newlands law of octaves. The first is that the law was applicable only up to calcium, because when seen in this table and as compared with the modern periodic table, not all the 8 elements have properties similar to the first element after calcium. They have huge variations in physical as well as chemical properties. And then the point to be noted is that he had placed 2 different elements in the same slot so as to accommodate all the elements into his table. And another point is that he had placed iron with oxygen and sulfur, though they had extremely varying properties, and had separated it from cobalt and nickel, though they had similar physical as well as chemical combining capacities and properties. Then, when the time Newlands had studied these elements, only 56 were available. And then he had assumed that no more would be discovered or artificially synthesized. So he had not left any place in his table for the newly discovered element which were yet to come. So thus, when the new elements were discovered, it completely disorganized the elements which were already placed in this table. And also, this table could not accommodate the neon gases, so the noble gases, which is usually called as the inert gases, and they had similar properties. The present elements which have here have similar properties, but the noble gases, they have completely different combining properties. As it was seen in the first point that the law was only applicable up to calcium, it is clearly understood that his theory does not work with heavier elements. So these were the limitations of Newlands law of octaves. And thus, there was a failure in his theory too. And after the failure comes one of the successful method, that is none other than Mendeleev's periodic table, which was given by Dmitry Ivanovich Mendeleev, who was a Russian chemist, and he had worked on it in publishing it between the years 1867 to 1871. And after the rejection of Newland's theory, Mendeleev's periodic table was warmly welcomed by many people and also by scientists. Mendeleev started studying different properties of elements by studying their combining capacities with hydrogen and oxygen. After studying them, he wrote them down separately, each on a card, and pasted them on a wall. After pasting them, he realized that all the cards, when placed in order of increasing atomic mass and similar properties, they gave formation of a table. So this table is none other than the Mendeleev's periodic table. While doing this study, Mandela observed that most of the elements got placed in the table according to their increasing order of atomic masses. So here we need to focus on main those three words, most of the elements and atomic masses. So this is going to be the cause of major drawback for Mendeleev's periodic table, which we'll be discussing very shortly. The second observation he did was that similar physical and chemical properties had a periodic recurrence in the elements. So the physical and chemical properties, they showed the recurrence or repeatance in the elements, that is none other than he observed periodicity in the elements. Based on his observation, he came up to a conclusion and stated the periodic law. After stating the periodic law, it goes as the properties of elements are a periodic function of their atomic masses, which can be easily explained as when the elements are arranged in order of their increasing atomic masses, there is a periodicity in the physical and chemical properties of elements. So this is it. And now we shall go on to discuss the advantages of Mendeleev's periodic table. It was the first systematic classification. Mendeleev, what he did was, after studying the elements, he started placing them together in order of groups from 1 to 7. There were 1 to 7 groups, and there were 6 periods in his table. And within the groups, he had formed subgroups A and B in order to accommodate the similar elements. But the only similarities between the two elements that he had placed was that they had the same valency. And he had also forecasted the existence of some new elements which were yet to be discovered, and they had similar properties like eka boron, eka silicon, and eka aluminium. So these, and he had kept blank spaces, Mendeleev kept blank spaces in his table so that when the new elements were discovered or synthesized artificially, they would be accommodated into that place without disturbing the position of the existing atoms. So thus, when the noble gases and many more elements were identified, they were placed without disturbance of the existing elements. The noble gases, they were placed in group 8. So now, as we discuss the advantages, let us go on to the limitations of the periodic table too. Dmitry Mendeleev, he was unable to properly exactly give the position of hydrogen. Hydrogen, being special in nature, could be placed even in first group as well as the 7th group because it showed properties of alkali metals as well as that of halogens. So he clearly did not explain the position of hydrogen. And then here comes the point where we had seen previously about atomic mass, the position of isotopes. Isotopes are the atoms of elements having same mass. So as a basis of classification by Mandela or Newlands or Poorinima was mainly atomic mass, and isotopes were existent for as well as for hydrogen and many other elements. They could not be explained clearly that where they should be placed. So the next point is wrong order of atomic masses. Mendeleev in his periodic table placed slightly heavier element before the slightly lighter element. There are two cases in this periodic table. One is for vanadium and the other is for cobalt. We can see that vanadium is heavier than chromium and cobalt is similarly heavier to nickel. So he had done this so as to maintain the similarity in the properties, and he could also not explain the position of lanthanides and actinides. In his law of periodicity, he stated that periodicity occurs, but he could not clearly state the cause of periodicity and why it occurs. So these were the limitations of Mandela's periodic table. With this, I'll be finishing my presentation. Thank you. Are there any doubts?
Hello students, any doubts? Yes? Yes, Poorinima, no doubts. I think सर्वांना periodic table समजलेला आहे. Okay. चलो सर्वांना समजला periodic table?
हे थँक्यू लय भारी केलंय.
Yes.
मी हे पहिल्यांदा बघितलं. THATNK बरं शब्द सापडलेत.
नाही, खूप भारी, इनोव्हेटिव्ह आहे.
गुड. नेक्स्ट आपण घेऊया अथर्व.
Yes, very nice, Poorinima.
Yes, sir.
Thank you.
Thank you, ma'am.